Bonjour. Welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I'm the teacher, Bronwyn Slate. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View Channel 972. You are always welcome to join me live through the Zoom link, which is available both from me, your teacher, and also your DEC. Our classes are scheduled Monday through Thursday from 10 until 11 in the morning, and we are now in our 5th week of our 9-week course. At this point, you should be submitting work for marking. So a reminder that the support questions, the ones with the pencil icon, are not for marking. These are practice problems. You decide which ones to do and how many of them to do depending on your individual needs. If you are understanding a concept, it is totally okay to skip questions. You don't have to do them all just because they are there. But I strongly encourage you to do the questions to make sure that you have a solid understanding before submitting your work for the key questions. The answers are in the back of your booklet, so check your work to make sure you're on the right track. The key questions, the ones with the little key icon, are the ones to submit for marking. So please do all of these questions. These ones I'm marking everyone, so you need to hand it in everyone. Show all of your work, your steps, and your thinking. This way, if you make a mistake, then I have more information as to why you made the mistake, and I can give you part marks. But if you just give me the answer, then I have very little information about how to help you improve. So how do you submit your work for marking? Well, there's 3 methods. The first is to scan your work and send it in electronically. If you have a device, you can scan your completed work using that device. Apple devices come with a Notes app that has a scan function, and Android devices come with a Google Drive app that has a scan function. These are fairly straightforward, point and click. If you need support though, on my YouTube channel, there are tech tutorials that will walk you through how to use both of these apps. If you need to send me pictures, that is fine too. Pictures are just generally a little bit bigger and a little bit more to send, but it's not a big deal. We can totally deal with that. Then you can send them to me by email to studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca. Or you can send it to me through Facebook Messenger, where my name is B.Slate Wahsa. The second method is drop your work off in Sioux Lookout. We have an outdoor mailbox at 74 Front Street. We're the bright red building next to the post office and have a small white mailbox next to our side entrance. So you can just set your work in there at any time. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. Students can also send their work by fax if you have access. However, sometimes things get lost in the shuffle, so just give us a heads up that it's coming. If you want to connect with me through social media, both my Facebook and my YouTube channel are under the name B.Slate Wahsa. All of our radio Zoom classes are recorded and uploaded shortly after broadcasting to YouTube. So you can find them all there. We have a playlist called MBF3C where all of our current and previous lessons are available so that you get all the information and you can go at things at your own pace. There's also short videos that explain common errors and confusing concepts. So if you're struggling with something or you keep making the same mistake, that's a good place to go and check out to see if there's something there that I've addressed that maybe will help you. Math is a really, really visual subject. So I strongly encourage you to access the videos. Either joining me live for Zoom, you don't have to talk to me, you can just watch, that's totally fine. Or watching the YouTube videos at your own time are both great options. If neither of those work for you, let me know, and I'm still happy to send you a copy of the recordings so that you still get the full experience and set yourself up for success. So if you have any questions or concerns, please reach out and connect with me. My email address is bronwyn.slate@nnec.on.ca. My Facebook is B.Slate Wahsa. Give me a call at the office at 807-737-1488, extension 2209. or toll free at 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m., though I teach from 9 until 11, so that is not a good time to try to get a hold of me, as I will not be at my desk. Today, we are continuing with lesson 11. Lesson 11 is looking at trigonometric ratios. In our previous session, we looked at how to solve for unknown sides, and now we're going to look at how to solve for unknown angles. So our learning goals are the same, that you'll be able to recognize and label parts of a right triangle, and you understand how to use trigonometric ratios to find unknown sides and interior angles of right triangles. The success criteria are that you can identify the opposite and adjacent sides as well as the hypotenuse side, and you can solve the unknown sides using trig ratios, and you can solve for unknown angles using trig ratios. This third one is what we're going to be focusing on today. But first, as always, let's activate your brain with a bit of mental math. I don't believe in math minutes. They cause stress and anxiety in students more often than not. And so I don't think that we should do them. Instead, I think that we should develop skills that we're comfortable with and we can transfer into various situations and really mean that we can understand what it is that we are doing and why. So today's question is 704, take away 486, and we're going to be using the concept of adding up. Adding is generally a little bit more friendly than subtracting. So with this, we're going to be starting at our lower number and working our way up to see how much it takes to get to our higher number. This is a strategy that lots of folks use, particularly when they're counting with money and coins things, is something that works really well for them. So we're going to add up. We're going to start at 486. We're going to add up until see how much it takes to get to 704. And we're going to be using friendly numbers. So I'm going to add 4 to 486 to get to 490 because I know that that's friendly. Then I see 490. Well, if I add 10, I'm going to get to 500. Now from here, I can jump and add 200 to get to 700. And then I can just add 4 to get to 704. Okay, great, we got there. But what's our answer? So what our answer is the bits that we added. So we have 4 plus 10 plus 200 plus 4. Well, I can see that that's going to be 200. And then 4 plus 4 is 8 plus 10 is 18. So the difference between 704 and 486 is 218. And that is a great way to do subtraction, is by actually adding. Totally fine. All right. Mine's on what prior learning do we need? I'm just going to quickly review the triangles. Again, if you watch the first part of lesson 11, this will be review, but review is good as it helps it actually stick in our brains. Oh, and this part is also, we're looking at angles, so this part's a little bit different. So the interior angles of a triangle, whether or not it's a right angle triangle or not, always add up to 180. So there's different ways that we refer to our angle, our vertices, which is where our angles are. But here I have like a triangle and labeled ABC. So that means that A, B, C, if we add A plus B plus C, they're going to always equal to 180 if it's an actual triangle. Same here. I have a triangle X, Y, Z. X plus Y plus Z is going to equal 180 degrees every time. So that's just something to remember as we go through and are looking at the angles part of this lesson. So what new concepts are we looking at? A reminder that trigonometric ratios are the ratios of any two sides with a right angle triangle in terms of the reference angle. Sine, cosine, and tangent ratios can be used to find both unknown sides and unknown angles. So again, we're going to be looking at the sine ratio, the cosine ratio, and the tangent ratio separately, but you'll see that they have very similar patterns. This is back to page 2 on your IELTS booklet. We're going to first review what the sine ratio is in case you haven't watched the first part of lesson 11, but even if you have, to just remind you, as this can be super, super confusing. So it's important to review to really get it to make sense. So we have a triangle, a right angle triangle, and the hypotenuse is always the side that's longest and that's across from the right angle. Remember, the right angle is this square indicator. Hypotenuse is always across. We label it, I label it as HYP. You can label it as H. You can write down the whole word hypotenuse, whatever works for you. The reference angle is always the important angle in situation, and this has to be defined. You can't just guess. It has to be told to you in the question in some way, and it's also never the right angle. So a way to indicate it is by giving it a letter or a symbol in the actual angle, and the angle, if we know the degrees, the angle of measurement, they'll give it to us. If we don't, then there might be a question mark, that might be a symbol, there might not be. So, but that is our angle of reference. The opposite side is always opposite the reference angle. So, and again, I label that with OPP. You could label it with opposite. You could label it with O, whatever works for you. With sine, the ratio, the relationship between sine is defined as the length of the opposite side divided by the length of the hypotenuse side. That ratio, no matter the size of the triangle, is going to be the same for the same measure of reference angle. For short, we can say sine equals opposite over hypotenuse. And for short form for writing it, I often write sin A equals OPP divided by HYP. Another way that people remember this is by saying SOH, SOH is another way you can remember it if that works for you. Okay, so then how do we actually use this information to find the angle? And this is on page 6 of your IELTS book. This is what we're doing that's new today. So we have a triangle, a right angle triangle. We see that we have a reference angle R. This time we don't have a measurement for it, but we know that we have a side that is 33 degrees and a side that is 33 meters and a side that is 48 meters. So we have a reference angle. So we're going to label our sides. The side 33 is our opposite. The side 48 is our hypotenuse. It's across from our right angle. As you've noticed, my triangles are all sorts of different orientations. So it doesn't matter the way that the triangle is oriented. You have to look for the information, the right angle symbols, the reference angle. These can be in various places. So because we have opposite and hypotenuse, we know that we're going to be using sine. So sine R is equal to opposite over hypotenuse. But this time when we fill in our substitute in our information, we have both of our numbers for our side lengths and we don't have our angle. So we have sine R equals 33 divided by 48. So this is why it's different. So we can do that division, 33 divided by 48, and we're going to get 0.6875. You're going to actually get a much longer decimal most of the time. You need to use at least 4 decimal places, maybe 5 if you want to, but 4 is good enough. But if you just do 1 or 2 decimal places, if you just said 0.6 or 0.8, you're going to get dramatically different answer. So you need to have 4 decimal places to get accurate information. So then how do we go from here? How do we figure out what our angle is with that decimal? So historically, when I was in high school and learning about this, we were given these pieces of paper that had all of these different information on them. And what this is doing is that it's telling us all of the ratio information. So for every angle, it doesn't matter if you're zoomed in or zoomed out on your triangle, right? These ratios are the same. For every angle, there is only one sine relationship, right? There's only one relationship of the opposite over the hypotenuse, and it's always the same for every angle. Doesn't matter if your lengths are bigger or smaller, but the relationship between the two is always going to be the same. So there are these tables that you can find online that tell you all of the different angles. So it has a list of angles. It has its corresponding sine ratios to 4 decimal places, you will see. And you can go through and you can pick out the closest one. So we have 0.6875 is our sine. So we're going to look in the column that says sine above it and try to find a number that is closest to 0.6875. So you can see right here, 0.6820 is the closest that we can get. So that means that our sine is 0.6820. So our angle is 43 degrees. So we can say, by looking at these charts, we can say that our angle is approximately 43 degrees. Now, we have technology and we don't need to rely on those pieces of paper anymore. Now we have calculators and the calculators hold all that information. So what we're going to do is we're going to use this notation that says sine inverse. So sine inverse looks like SIN and then it has a superscript of -1. You might call it sine -1. I'm going to call it sine inverse. That's the correct mathematical term. And just the way that my brain works, that's what I'm going to call it. And so this is doing the opposite. It's reversing sine. So just like division is the inverse of multiplication or subtraction is the inverse of addition, they're the opposite. Sine inverse, sine -1 is the opposite of sine. So it says, what it means is that it say, okay, if I say sine inverse of 0.6875, I'm saying if this is my ratio number, what is the corresponding angle to go backwards? And you're going to find that on your calculator. So on your calculator, this is the, generally, in my experience, I've always seen it to be the second function of sine. So on your calculator, you will see it'll say sine, and then it'll be have above it, it'll say sine -1, sine inverse. If you're using Desmos, that's not what I want. If you are using Desmos, here on Desmos, I'm going to make it big so you can see. You go to, see, we have sine, cosine, tan on our main, when we just open up our scientific calculator. Here, if we go to function, then here it's going to tell us sine -1, cos -1, tan -1. This is where our inverse is going to be. They also still have the sine, cosine, tan here. That's just how they do it. The other thing you'll notice is that here you have it in degrees. So here I can click it to see if it's in radians, RAD, or in degrees. It's always going to be, generally going to be in degrees when you start it. So you need it to be in degrees in your Desmos as well. So if we do our sine and then you put in 0.6875, we'll see that we get an answer of 43.432 long decimal. So you can see it taps into those charts that we looked at, those references, and it gives us some more detailed information because it's a computer and it holds a whole bunch of information. Your calculator is a computer and it can hold a whole bunch of information. So that's how you use your calculator to find your inverse, to find your angle. So now we can see that our angle R is 43.4 degrees. If you use the paper and you just say it's about 43 degrees, that's okay. But using the calculator gets you more exact information. Again, your calculator must be in degrees, always in forever. That's the unit of measure that we're using. So you need to make sure that that's the unit of measure that you're using. All right, now you can do the support questions on page 6, questions 5 through 7. We remember did 1 through 4, and those were solving for the unknown sides. Now you can solve for the unknown angles. All right, let's look at cosine. This is on page 7 of your IL booklet. And again, we're going to review how the cosine ratio is defined. So we have right angle triangle. Our hypotenuse is still always the longest side, which is across from your right angle. Your reference angle is still the important angle in the situation, and it again is never the right angle. It has to be told to you, it has to be indicated in some way. And your adjacent is always the side that is next to or adjacent the reference angle, the one that's right beside. I like to call it ADJ. You can just call it A, you can write adjacent, what works for you. So the cosine ratio is the relationship between the length of the side adjacent to your reference angle divided by the length of the hypotenuse side. So that's how cosine is defined. So you can just short form say it cos A is equal to adjacent over hypotenuse. Or you can write it, I write it out as cos A equals ADJ divided HYP. That's how I write it out. You can also use the CA, the CAH, if that is helpful for you to remember. If that's another tool that you can totally use. Okay, so then how do we use this to find an angle? This is on page 10 of your IL booklet. So we have a triangle that is a right angle triangle. We have a reference angle B, no angle measurement there. We have a side length that is 37.2 centimeters and a side length that is 85.9 centimeters. So we can label our triangle first. Adjacent is, we know, which is 37.2 centimeters. And the hypotenuse is across from our right angle, which is 85.9 centimeters. So because we have adjacent and hypotenuse, that means we are dealing with cosine because that ratio compares adjacent to the hypotenuse. So we have cos B equals ADJ over HYP. So then we fill in our values. We substitute in our known values. So we have cosine B equals 37.2 divided by 85.9. Again, we have our side lengths. So we can do that division and we get cos B equals 0.4331. Still rounding it to 4 decimal places at least to get more precise information. And then now, again, we can go and look at the tables of the cosine tables, and you can see that this tables are different than the sine table, right? Because we have an angle. It's still listing all of our angles, great. But now we're listing our cosine relationships, and our cosine relationships are going to be different than our sine relationships because we're comparing our adjacent side to our hypotenuse opposed to our opposite side to our hypotenuse. So again, we can look it up. We can say, okay, we're looking for the number that's closest to 0.4331. And that is over here. We have 0.4384 is our closest, which is at an angle of 64 degrees. So our angle is about 64 degrees based on our chart. Or using technology, we can write the cos inverse, which is cos to the -1 of cos B equals cos inverse of 0.4331. Now, a mistake that students often make, I'll write it down just so that you can see it and then I'll erase it. This is wrong, so don't do this. But students often will say cos B equals cos inverse of 0.4331. Once you have a cos inverse, you have to do it. This is the inverse operation of cos. So you have to do it on both sides, just like when you are solving, you're rearranging for algebra and you need to make sure that you're keeping your equation balanced. You can't just put the cos inverse on one side. You have to do it on both sides. Okay. If you are lazy, which is totally reasonable, if you want to be efficient, you don't want to write it all out. Instead of writing the cos B, you could just write angle B equals cos inverse of 0.4331. You could write it like that instead of writing this step with the cos inverse on both sides. But you need to either do this step where you have the cos inverse written on both sides, or if you're writing the cos inverse on one side, then you need to stop writing the cos on the other side because it's no longer there. That cos inverse has canceled it off. If you're unsure about that and you want to talk more about it, please let me know. We can chat more about that notation. Okay, so then again, we're going to use our calculator. Our calculator button is going to be the second function of cos. just like we saw on Desmos, it is still there in that second function menu. You press the button that taps into the detailed charts that it has in its little calculator brain, and we get that angle B is equal to 64.3 degrees. And that's all we need to do. Of course, our calculator has to be in degrees because we're talking about in degrees. If it's RAD or GRD is what your calculator says, then you need to press that DRG button until you get into degrees. We're using degrees as our unit of measurement. Now you can do the support questions on page 11, questions 12 through 14. And then finally, we're going to look at the tangent ratio. This is on page 12 of your IL booklet. First, we're going to define the tangent ratio. So this is applicable to right angle triangles. The reference angle is still your important angle that they have to tell you in the situation, and it's never, ever the right angle. That's your first piece. Then you have your opposite, which is always across or opposite your reference angle. And then you have your adjacent, which is always next to or adjacent the reference angle. So those are the two parts that you need, the two sides that we're comparing, because the tangent, so tan A is equal to the length of the side opposite the angle A divided by the length of the side adjacent to the angle A. That is the ratio that we're comparing for this angle. So I just say tan A equals opposite over adjacent, and I write that down as tan A equals OPP over ADJ. I still say tan A equals opposite over adjacent, but I write the short form. And if you want to use the 3-letter memorization trick, if that's useful for you, you can use TOA, which is TOA, tan opposite adjacent, if that works for you. So how do we use that to solve an angle? This is on page 15 of your IL booklet. We have a right angle triangle. We're solving for angle M. So our angle M is our reference angle. We have a side that is 19 centimeters and a side that is 33 centimeters. So we want to label our triangle first. So our side that is opposite is 33 centimeters. Our side that is adjacent is 19 centimeters. So we know because we have opposite and adjacent that we're going to do tan of M is equal to opposite over adjacent. We substitute in our values. Tan M equals 33 divided by 19. We're going to do that division. And we get tan M equals 1.7368. Still round to 4 decimal places. That is still true. But you will notice that tan often will be greater than 1. Our opposite side could be longer than our adjacent side. When we're doing sine or cosine, our hypotenuse is always longer than our opposite or adjacent side. That's by definition. So it's always going to be less than 0. Sorry, less than 1. My bad. It's going to have 0 point something. With your tangent, your opposite could be longer than your adjacent, not necessarily, but it could be. And so you might have a value that is greater than 1. Still need to write it 4 decimal places. So this time you have 1.7368 instead of 0.7368. So, but you still need to have the 7368. That's the 4 decimal places, the 4 points after the decimal. So then looking at the tan chart, you can see still have our angles, but our tan ratios, you can see are different numbers, and you can see that we go up, that once we get above 45 degrees angle, we're going to be above 1, and that keeps going up and going up and going up until we get our tan can even be up to 57. Our ratio can be up to 57.290, which is 89 degrees. So you might get a really big number. So that's just something to be aware of, that could happen. Here where it says 90 is infinite, don't worry about that for now. That's just, it's all good. So we're going to try to find where On our tan chart, we have 1.7368, what's closest. So the closest thing we have is 1.7321, which is 60 degrees. So that means that this angle is roughly 60 degrees. So using technology, we can do tan inverse of tan M is equal to tan inverse of 1.7368. All of the things that I've talked about are still applicable for sine, cosine, and tan when you're using your inverse in terms of how you write things down. It's all the same. It's just we're talking about different ratios. On your calculator, your tan inverse button is going to be the second function of your tan button. If you can't find your inverse, your tan inverse, sine inverse, or cosine inverse, let me know, and we can look at your calculator together to see if we can figure it out. All calculators are different, so generally, I don't think I've ever seen a calculator, a physical calculator, where it's not just a second function, where you have to press second or inverse. But if you don't know your calculator, you can't figure out where that button is, let me know, and we can figure that out. Then we do that, and we get that angle M is equal to 60.1 degrees. And of course, our calculator must be in degrees. All right, so now you can do the support questions on page 16, questions 19 to 21. So you can do all the support questions now in lesson 11, both the unknown side ones and now the unknown angles. There's a whole bunch, but as you will have noticed, hopefully they're very similar. Yes, there's a lot of questions, but hopefully with the practice, you'll be comfortable and you won't be confident with it. You won't have to think too hard about it. So check them out. But again, as we talked about in our previous part 1 of lesson 11, which ratio do you use? That is the tricky part. That is the hard part to figure out. Doing the steps are the same, but figuring out which ratio and therefore which button you press on your calculator is key, as otherwise you will get completely different answers. So we're going to walk through, again, the steps that you should check to figure out which ratio to use. Again, I strongly encourage you to screenshot this at the end once we've gone through all of the 4 steps to make sure that you can refer back to this if you need to remember the steps. So the ratio is decided based on the information that is in the question. The question has to give you the right information. They're not going to tell you what the actual ratio is, but they're going to tell you the pieces in some way or another. So step 1, confirm that your triangle is a right angle triangle. That is what you always have to do. Trigonometry ratios, these 3 ratios, sine, cosine, and tangent ratios, only work if you have a right angle triangle. We're going to be looking at some other things you can do if you don't have a right angle triangle in the next few lessons. But at this point, if you have a right angle triangle, this is your best bet. And this only applies if you have a right angle triangle. So yes, we have a right angle triangle. Step 2 is that you want to label the sides of your triangle. So again, you need to find your reference angle. That's your start, because your sides are in relationship to your reference angle. And then you have your opposite side across from it, your adjacent side beside it, and your hypotenuse, which is across from your right angle. I always encourage you to label all of your sides, and it's really, really good practice. Then from there, step 3 is identify the information that you know and what it is that you're solving for. So we know our adjacent side in this question. We know our hypotenuse side. We don't know our reference angle. We know which one our reference angle is, but we don't have the measurement. That's what I mean when I say we don't know our reference angle. So our reference angle is unknown, and that's what we're trying to figure it out. So then we do step 4, we choose our ratio. So we look at our 3 options. Sine B is opposite over hypotenuse. Cosine B is adjacent over hypotenuse. Tan B is opposite over adjacent. When we look at our question, we say, okay, well, we know our adjacent, we know our hypotenuse. We're looking for a reference angle, adjacent and hypotenuse. That means we have to use cosine. that is the only ratio that talks about adjacent and hypotenuse. So that is how you pick your ratio. It's because you have to go through those steps to figure out which information you know and don't know, and you're going to be able to use. These steps, you don't have to write them down. You don't have to actually do anything when you're doing these steps. It's just, this is what you want to be running through in your mind in order to pick what your ratio is. Over time, you are likely to get comfortable with this and aren't even thinking about them as 4 different steps. But when you're starting, if you need to, go through these steps to figure out which ratio you're going to be using. Okay, let's do some practice questions to figure out what it is, again, what all this is. All right, number 1, we're going to calculate some ratios we're just going to go through a user calculator to figure out what these are. So A is tan inverse of 5.9328. We do not need to use the charts. We are just going to be using our calculators because technology has evolved such that we can. Just knowing where they come from can be useful. So on my calculator, I'm at the function where I have tan inverse. So I put in tan inverse 5.9328. Again, you also have to know what your calculator, if you press the tan inverse button first, or if you press the ratio in first. Different calculators do it different ways, and you don't know until you have your calculator in front of you. Okay, so that tells me that this is angle 80.43 degrees. Angles, I generally say, I just write it as 80. I round it to 1 decimal place is my habit. You can decide what works for you. I don't have an angle letter, so I just put angle equals, but really I should probably just say equals. It's a little bit awkward notation. Sorry about that. Okay, so then part B, we have sine inverse of 0.4271. That equals 25.28 degrees. So I would say 25.3 degrees. And cosine inverse of 0.0256 is equal to 88.5 degrees. So as you can see, these sorts of questions, you're just using your calculator. You're just practicing using your calculator to get comfortable with it, which is super important. Okay, next type of question. So here we have calculate angle n to the nearest degree. So now we have sine n equals 0.5922. So we need to put the sine inverse notation in order to figure out what our angle is. Our math that we're going to do isn't actually different, but our notation, our steps are different. So to find angle n, we're going to take the inverse of both sides. So we have sine inverse of 0.5922, and we get 36.3 degrees. So angle n in part A is 36.3 degrees. I have no idea why sometimes my calculator goes away and sometimes it doesn't. Just the joy of technology. Okay, part B, we have cos n equals 9 divided by 13. Now we can divide the 9 by 13, or we can just take the cos inverse of 9 divided by 13. Again, I've written this in the different notation. I've skipped where I write cos inverse on both sides. I just went angle n equals cos inverse of 9 divided by 13, which is totally fine. So you can do that you can do the division in the cos inverse in the brackets, that's fine. If that works for you. If you want to write out, do the division and write down the decimal first and round it to 4 decimal places, that's okay. But that gives us an angle of 46.2 degrees. I'm just going to show you. So 9 divided by 13 is equal to 0.6923. So I'm going to show you why it's important to do the decimal places. So here we know that if we do it with the fraction, that's the most exact that we're going to get, and we get 46.1869385 because there's no rounding errors there. But here, if I just do 0.6 and because I just round to 1 decimal place, I get 53 degrees. So 53 is fairly far away from 46 because our degrees are small, right? So even though they're generally close numbers in the scale, they're pretty far away. 9 degrees is, 7 degrees is still pretty far away. If I put in 0.69, even just putting in that second decimal place, now I'm at 46.3, which is significantly closer than 53 was to 46.18. Then if I put in the 2, now I'm at 46.21, which also is really, really close to 46.18. And then if I put in my third, I get 46.187. So now, if I'm just going to round it to 1 decimal place, they're going to be the same. So this is why I tell you to do 4 decimal places, because 4 decimal places gets you really close to exact for our purposes. Whereas if you just round to 1 or 2 decimal places, you're still going to be fairly far off. And depending on the relationship, it's going to be different. So 2 decimal places might be kind of close for this one, but it might be far for another one. So that's why I say around to 4 decimal places, because you're still going to get you're going to get a really exact answer, opposed to if you want to do the decimal, that's great. Or sorry, if you want to do the fraction, that's great. If you want to do the division and then just use the decimal, round it to 4 decimal places so that you get as close to an accurate answer as we can. Okay, so then part C, tan n. So here, again, you can write it as tan n inverse of tan n equals tan n inverse of 35 divided by 29 equals angle n is equal to. And as you can see, there's multiple ways of writing this stuff that is still all accurate. And I am the type of teacher who is okay if you write it out differently than I do. I want you to still be accurate, but you don't have to write the same steps that I write out. What works for you is fine. So angle n in that example is 50.4 degrees. Another thing that I want to show you is I'm going to change on my calculator. So you can see I'm going to change it to radians and watch my answers. So as you can see, when I change it to radians, my answers jump. They change significantly. So now my angle is 0.8788. And that doesn't make any sense. That's not degrees, that's in radians, which is a unit of measurement, which we don't understand. So this is why it's super important for your calculator to be in degrees. You'll notice up here where it says 9 divided by 13, that number doesn't change because 9 divided by 13, we're not talking about angles. But here, whenever we have sine, cosine, tan, or the inverse of them, those numbers change because now we're talking about angles. So that's why your calculator has to be in degrees. This is why it's so important. Okay. Next question. Calculate F, angle F. We have a triangle. It's a right angle triangle. Before, when we were always calculating which ones, we were talking about either the sine ratio, the cosine ratio, or the tan ratio. So we had a pretty good guess which one we were going to need to use. This one, we don't know. It could be any of the 3. So we see that we have angle F. That's our reference angle. That's what we're trying to find. So we look and we say, okay, across from angle F is our opposite. Now, I often do this wrong and then correct myself. So it's okay to make mistakes. Then our side that is adjacent is here, which is our 12.1. And our hypotenuse here is across from a right angle. So to decide which one I need to use, okay, so I have my opposite, I know a number for that, and I have my adjacent, I know a number for that. So I have to think opposite and adjacent, opposite and adjacent. That is tan. So tan of F is equal to opposite over adjacent. Now, I've been doing these for many years. I remember these. If you don't remember them, you can look them up. At this point, look them up so that you know. With practice, you're going to know them more likely. If your brain just doesn't remember things like that, then look them up. Or if SOHCAHTOA helps you remember and saying, okay, SOHCAHTOA. So SOHCAHTOA. Okay, I have OA, so that's going to be tan. Now, for me, I'm awful at spelling. So SOHCAHTOA was never helpful for me because now that I've been doing this for over 20 years, I can remember how to spell SOHCAHTOA. But when I was a high school student first learning this, I could not. So that did not help me. So you figure out what works best for you. Now I'm going to substitute the values in, and I have tan F equals 8.4 divided by 12.1. Why don't we do the division this time? Again, as you've seen, there are various ways you can do these and still get to the same answer. I'm not attached to you doing it one particular way correctly, but there are lots of different ways that are correct. There's lots of different pathways to get to the right answer. So we have 0.6942. So then angle F is equal to the tan inverse of 0.6942. So angle F is equal to, so I'm going to go to tan inverse of my number, and I got 34.8 degrees is my answer. And that's how we do a question where we don't know which one we're going to do. We went through those steps and we figured out what our answer was. All right, we're going to do one more practice problem. Here we have calculate y. All right, so let's look. Now y is a side. So I have my reference angle here, and let's give it a name. Let's call it B, just because. So my reference angle, so then I'm going to label my triangle. And I have my opposite, my adjacent, and I have my hypotenuse. Okay, so in this case, I have a number for my opposite. It's my y, it's my unknown, but I have a letter for it. I have a number for hypotenuse, 173, and I have an angle for my reference angle. So I have opposite and hypotenuse is sine. So I have sine of B is equal to opposite over hypotenuse. So I feel I want to know, well, sine of B, so B is 28 degrees. Opposite is Y, hypotenuse 173. I'm going to rearrange to isolate for Y. So 173 times sine 28 is equal to Y. And now we're going to use our calculator. So even though this lesson we've been talking about angles, you can see it is not that difficult to do an unknown side question. If it shows up. There, you still just need to follow the same steps to figure out what you know and you don't know. and then I solve for what you don't know. So 81.2 is equal to y. That's the side length. So even if you're not prepared for, if they're mixed up, the sides and unknown angles, you can still do it. I believe in you. Okay. Unfortunately, we don't have time for this last practice question. It's a great one. I'm just going to read it and you can draw a picture. So Caleb uses a wheelchair. The ADA guidelines suggest that a safe, accessible ramp doesn't have an incline greater than 5 degrees. Caleb wants to enter a store that has a ramp that has a 6.1 meter that's long and a rise of 0.45. Is this store accessible? So you're going to think about your ramp, and this is actually true. This is actually things that people need to consider. So a ramp is 6.1 meters long, and it has an angle of doesn't have an angle. It has a rise. That's how far it goes up, 0.45. And we're looking for this angle. This is what we're trying to find. So you can go through to find your reference angle and see if that's greater than or less than 5 degrees. And that is going to define if it's accessible or not. All right, again, we don't have time for that word problem. So let's consolidate quickly the last things that we've covered. So for lesson 11, trigonometric ratios are sine, cosine, and tangent. And we have to label our triangle. This is so, so important. You really need to get comfortable with that. You can use SOHCAHTOA or sine A equals opposite over hypotenuse, cosine A equals adjacent over hypotenuse, or tan A equals opposite over adjacent to memorize whatever makes sense to help you understand and to remember. You decide for you. We learned how to solve for an unknown angle in the last lesson, and now we know how to solve for an unknown. Sorry, we learned how to unknown side last lesson, unknown angle this lesson, and we have to use that inverse function. As always, your calculator must be in degrees, super, super important. So hopefully you now can identify the opposite adjacent sides as well as the hypotenuse side. You can solve for the unknown sides using your trig ratios, and you can solve for the unknown angles using your trig ratios. As always, if you have any questions about any of this, this is a little math heavy, so totally feel free to reach out. If you're struggling with it, I'm happy to support you. Give me a call at the office at 807-737-1488, extension 2209. Send me email at bron1.slate@nnec.on.ca or send me a message on Facebook at bslate Wahsa. Thank you so much for joining me today. Good luck with this lesson and Miigwech.